talk about maximizing the revenue. Now, suppose we have the monthly revenue of the sale of Alaska sweatshirts. You know, I like to sell the Alaska sweatshirts, right? Are given by the function negative 0.1x squared plus 50x, where x is the maximum, x is the number of shirts sold. Yes, this revenue function has a little extra thing in it due to supply and demand. So let's first find the vertex and the axis of symmetry. So remember, negative b over 2a. So negative 50 over 2 times negative 0.1. So these negatives will cancel, and we're 50 divided by 0.2, which is 500 over 2, which is 250. So that's the vertex, or that's actually the x-coordinate of the vertex. So let's find what the revenue is when you sell 250 shirts. Negative 0.1, 250 squared, plus 50 times 250. Let's see what that is. Negative 0.1, 625 with 2 zeros, and 125 with 2 zeros. So this is negative 0.1. And so that's negative 625, 0 plus 12, 500, which is 6250. So we have our vertex is 250, 6250. What is the vertex? What does the vertex represent, a max or a min? Since this is negative, we have a sad graph, and that means this is a maximum. Interpret the vertex. So the maximum revenue occurs when we sell 250 shirts, and the max revenue we can get is $6,250. That's what that means. So that's really important, because you know I'm always making you guys interpret things. I know I'm weird that way. And so let's graph this function. So we know we have a point 250, 6250. 250, 6250, which would be right here. Okay, we know we have a 0 right there, and we can look at the point opposite the 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we're back here again. And so we know all this. Gosh, I'm terrible at drawing graphs. Oops, lost my... So we could also look at, if I go over 100, so I know the over 1 down 1 thing, but if I go over 100, then I would go over, then I would go down. So 10,000 of 0.1s, so I would go down 1,000. So if I go over 100, I go down by 1,000, which is about what I have here. Oh, 1 down by 1,000. I didn't do it so good on the other side. 350 right here. There we go. That's better. Okay. So there's my graph of the function. Pretty easy, pretty fast. Again, I could also have put that into my calculator fairly easily. And I know, and what's nice about this in this position is that I know exactly where to put the limits now. Because now that I can graph it by hand, I don't have to sit here and guess what the limits are. Oops. So I know if I go to window, let's see, what do I want? 0 to 600. There, I'm going to make this 100 just to make it look nice. Y min is 0, Y max 7,000. I'm going to make my Y scale 1,000 just to make it look nice. And look. Oops, what happened? Did we make a mistake? Oh. Oops, I forgot to square my first x there. Okay, so that is insert x squared. Oops, no, we don't need that one. Okay, does that look better? Yes. Now let's graph it. Now it'll be right. And there we go, just like we saw before. And we have exactly the same picture. So really nice. Now we can graph something on our calculator. We can kind of know where to put it. So now I'm going to ask you this question. For what x values is my function increasing? So I'm increasing, if you can see, from x equals 0, well, even below that, but that doesn't make much sense because I can't sell less than 0 product anyway. From x equals 0 up to 250. So from 0 to 250, up at 250, I'm not increasing, I'm saying the same. So I can also say from 0 to 250. This is really, really important. So from 0 to 250, I'm increasing. And that's my increasing. And I'm decreasing from 250 to, where else do I hit the axis? 500. So what does this mean in the context of this application? That means my revenue is going up until I sell 250 shirts, but starts going down after that. So basically what's happening is after that many shirts, I'm starting to saturate the market. So I'm not making as much money anymore. My revenue is decreasing. I'm having to mark my shirts down after this. So I can sell about 250. Demand is there for about 250 of them. After that, I can't do it anymore. I start having to mark them down and lower my price to get rid of them. Okay, so let's talk about the height of a ball. This is always fun. So I'm sure you've seen these kind of problems before. So a ball is thrown upward at 32 feet per second from the ground. From the ground? Okay. Write the quadratic function that models the height in feet of the ball. So I've put part of the solution on here. The model has this form. This is how we model a ball. Oops, stop doing that, you darn thing. Goofy thing. Okay. There we go. So -16, that's feet per second squared. That is actually the force due to gravity. And that is always in there. That's the gravitational constant. And then v sub 0 is our initial velocity. So if we throw it upward at 32 feet per second, then what we call our initial velocity is 32. And if we're throwing it from the ground, which good luck with that. I don't know how we're throwing a ball from the ground. We must be standing in a pit. We're going to throw it right from 0. And so our model becomes S of t is -16t squared plus 32t. This goes to 0. This is 0. So that's all we have there. So we want to find the coordinates of this graph. So what is the vertex? Negative b over 2a would be negative 32 over 2 times negative 16. Yeah, that's right. Okay. So negative 32 over negative 32 is 1. So if I plug 1 back into that equation, s of 1 is negative 16 times 1 plus 1 squared, whatever, 32. So 32 minus 16 is 16. So that is the height of s in the function of time. So the t coordinate of the vertex is 1 second, and that isn't when it reaches its maximum height. And the s coordinate is the value at t equals 1. So x equals 16. So at 1 second, it reaches its max height of 16. Okay, so, and for some reason this doesn't want to move, does it? Okay. So finally, we're going to graph this model that we just made. So we know that at 1 second, we are 16. So we know that's the vertex. And we can see that when we go, if we went 0, if t was 0, we would be 0. We can also set this equal to 0, oops, not 16 squared, t squared. We can also set this equal to 0, pull out a negative 16t, we're left with t minus 16. So this is 16 equals 0. Oops, that's 2, and t equals 2. So we can see that, it's just going to be a weird parabola, but that's okay. There's the time, and the max height of the ball is 16 feet in the air. And then it comes back down and hits the ground again after 2 seconds. So, what is the meaning of the coordinates of the vertex? Well, it hits maximum height at 1 second, and the max height that it hits is 16 feet. So we'll do some more fun things with that in class. We'll give you a chance to write that down. It hits a maximum height at 1 second, and the maximum height is 16 feet.